Alright guys, so this is going to be the first lecture of Unit 3. So you should have the PowerPoint packet in front of you. So this packet is going to be on bonding and a few other things. So before we really get into it, I want to kind of wrap yesterday up because it's going to help today. So yesterday I wrote on the board, I want you to be able to, by the end of the day, distinguish between an ionic bond and a covalent bond if I simply give you a formula. So at the very top, I want you to write this down and we're going to add some stuff to it. So does anyone remember what two types of elements you must have for an ionic bond? Very good. So ionic is between a metal and a non-metal. Okay, that's the most important part. But that's not good enough because if I say where are the metals, if you don't know where the metals are, that's not going to help you out. What was the key indicator on the periodic table to tell you where they are? Very good. That orange line on that one and this red line on this one. So, which side are the metals on? Okay, so the metals are on the left of the, and I'm just going to be lazy and abbreviate stair step SS. If you want to write stair step so you know what it means or give a little key on the side. So the metals are the left of the stair step. Okay? Where are the non-metals? Okay, very good. So it's to the right of the stair step. So in all, in order to get, I'm going to try to get this back. I'm going to say this back. In order to get an ionic bond, you've got to have at least one from the left, one from the right. Correct? Now, there's one exception. There's one element on the left side of the stair-step line that doesn't act always like a metal. And who is that? Very good. So we have one exception. Okay? Now, it can act like a metal, but for the most part, it truly acts like a non-metal. Now, it's easier to see it on this periodic table, on the one to your left. Someone look at hydrogen and kind of give me an easy clue of why it's not a metal. It's red. What does red mean? It's a gas. When? Room temperature. Very good. So if it's a gas, it can't really be metal, right? That doesn't make any sense. Now, it does have times, it does have properties, it does have opportunities where it can actually act like a metal, and we'll talk about that later on. Okay? So this is just a very general, quick synopsis of ionic bonds. I'm going to dig deeper into this, and we're going to talk more about an ionic bond. So let's go to the other side. Covalent. What do you have to have for a covalent in terms of atoms? Very good. Now, I want you to write it this way. There's a reason why I don't say two non-metals, and I'm going to give you the specific example in just a second. Now, so two non-metals, where are they going to be in terms of the stair-step line? To the right of the SS. Now, I know this sounds silly, but I'm going to add it again. Who's the exception? Except hydrogen. Okay, hydrogen's that one exception. Yes, it's to the left, but it does act like a non-metal. Now let me give you two examples of the reason why I use the word multiple non-metals. Now the first one's going to fall right into that category. So the first example is H2O. Now, before I actually go into the description, I want to ask this question, because this was question number 10 on the question yesterday. Does the number matter? No. Did that little number tell you anything about it being an ionic or covalent bond? That had nothing to do with it. It was only, is it a metal or a non-metal? So let's just ignore the numbers. Okay? Is H and O both non-metals? Yes. So we qualify this as a what type of bond? Covalent. Now, let me give you another example. And again, it's the reason why I use the word multiple. What is that, first of all? What kind of sugar? glucose. Come on, people. Glucose. Yes, ma'am. When all these other people get yes. So the point being is this. Is there more than two? Yes. Is it still covalent? Yes, and that's why I say that. Any biomed students in here? Biomed down DC? Y'all work with these big, huge strangers, right? These can get really big. There's some carbon ones that are 40 and 50, 60 large. I mean, it gets really big really fast, especially in biomed and biochemistry. So, all in all, if we can at least do what's on the board in front of you, this chapter will get a whole lot easier, a whole lot faster. Simply being able to identify, is this compound, whatever's in front of you, ionic or is it covalent, will help you out immensely. Okay? Now, there are going to be some deeper sets of knowledge we're going to talk about, but all in all, this is going to be the minimum that we've got to do. So again, bonding, molecular geometry, and IMF. So let's start with this. How many of you despise that word? All right. I'm going to give you some good news. It's not like math geometry. The only thing that we're going to be dealing with this word, and I do want you to write this down, we're going to be talking about shapes. Because do molecules have shapes? Yes. Absolutely. We're going to talk about what are the shapes of those molecules. I'm going to go all the way back to like the first or second day of class. Do you guys remember that acronym? Yes. Do you remember what it stood for? Fantastic. If you don't, write it down. Intermolecular forces. Good. I'm glad to hear that. So again, let's break it down. What does inter mean? Between. Between. Moleculars, molecule. Forces, force. So an intermolecular force is a force between molecules. Everybody okay with that? That's what that means. We're going to talk about the three of them. If you want to just jot this down just as a nugget, there are three of them. Okay? I'm going to show you four, but we're not going to talk about the fourth one. I'm just going to show it to you and just make mention of it.
Okay, so now you said you could test on like unit 2C.
Yep.
Is this also everything?
This is a totally separate deal. We're going to be doing both at the same time. Okay? Yep. All right. So put a big star beside the second bullet. If you want to write TQ, if y'all know what TQ is a test question. The second bullet and the third bullet are test questions. Okay? So first and foremost, why does this chapter matter? Because if the first bullet weren't true, we wouldn't even have to do this chapter. Okay? Atoms rarely exist as independent particles. So what that means is, out in nature, will you ever see just a nitrogen atom hanging out by itself? Or you ever see just an iron atom just sitting there by itself? No. So typically atoms create bonds. Okay. I don't know where Destiny is. She knows So, again,